Hello friends, welcome to Independent Learning. My name is Raj Shah, and in this video we'll be looking at the theorems on chords, and we'll be looking at some examples also based on those theorems. Okay, so in the previous video we saw the introduction of the circle, the chapter circle. We saw what is radius, what is a diameter, what is a chord. Okay, so in this video we'll be looking at some theorems. Okay, so let us start. So here the first theorem which says a perpendicular, so this is a perpendicular, I have written it in short. So a perpendicular drawn from center of a circle on its chord bisects the chord. So here's the diagram. Okay, a perpendicular drawn from the center. So O is the center of the circle. Okay, so I'll just write it. I'll just write what is given. O is the center. Sorry for this. O is the center. Okay, AB is the chord. AB is the chord. Okay, and P, see, a perpendicular drawn from center, so it is drawn from the center of a circle on its chord, so it is meeting at point P. It is drawn at point P. So we'll just write it's perpendicular, right? So we'll say OP is perpendicular to AB, because it is said that the perpendicular is drawn from a circle, from the center on the chord. That means from the center, which is AP, is perpendicular to AB. So I can say that both angle OPA and OPB, they both are what? 90 degree each, right? Because they are perpendicular. Okay, so what are we supposed to do? So a perpendicular drawn from the center of a circle on its chord bisects the chord. We need to prove that if this is given, we need to prove that it bisects the chord, means it divides this perpendicular, okay, divides the chord which is AB into equal parts. Means to prove segment AP is congruent to segment BP. Correct? What does it mean by the word bisect? Means it divides into equal parts. So the question says, the theorem says that this perpendicular bisector, or this perpendicular, okay, this perpendicular which is drawn on the chord, it bisects the chord, means it divides this chord, this whole AB, into two equal parts, which is AP and BP. That's what we need to prove, that it bisects into equal parts. Okay, so that's what we need to prove now. So here we are constructing, means joining OA and OB. Okay, so we'll write that construction, okay, join OA and OB. Now if you see, is AB, what is OA and OB? Is it not the radius of the circle? Because radius is what? From the center to any point on the circle. That segment is called what? Radius. We did in the previous video. Okay. So OA and OB, they are what? The radius of this circle. So we can say join OA and OB, or you can say radius OA and radius OB. So you can say join radii OA and OB. Okay, so you can adjust this, join radii OA and OB. Okay, so now we'll look at the proof. Okay, we need to see, if you before starting with the proof, we need to prove that AP is congruent to BP. Now if you remember previous chapters, parallel lines, quadrilateral and others, if you remember, to prove these two sides to be congruent, can we do in a way by proving that these two triangles, considering these two triangles, proving them congruent, and then easily we can say that this side and this side is congruent. Yes or no? The easiest way. So what we'll take this triangle and the other triangle also, which is OAP or OPA and OPB. So we'll take these two triangles and we'll prove them as congruent by the number of tests we have, whether it's ASA or SAS or SSS or hypotenuse side test. Okay, and if we are able to prove these two side triangles congruent, then we can say that AP is congruent to BP. The reason will be CACD, congruent sides, which is CSCT, sorry. So congruent sides of corresponding sides of congruent triangles. Okay, so let us start with the proof. See, before me writing the proof also, you have understood now how we are supposed to solve. So I hope before starting me writing the proof, I want you to pause the video and try to write it on your own and cross check with what I'm writing here now. Okay, so let's see the proof now. Okay, so here we'll consider in triangle OPA and triangle OPB. So we have considered these two triangles, this and this, correct? Now if you see OP is perpendicular to AB. So can I say this is 90 degree, this is 90 degree, meaning OPA is congruent to OPB. Why? Angle OPA is congruent to angle OPB. Reason for this? Because both are 90 degree. Yes or no? Each of them angle is 90 degree. Therefore, we'll say each angle is 90 degree. So each angle is 90 degree. Okay. So we get this. Now, if you see, this will be congruent to this. Can you tell me why? Because, okay, I'll just write it. OA is congruent to OB. Reason for this? Radius of the, we can say, or radii of the same radius of the same circle. Because OA and OB, they both are radius, and radius of the circle is always same. So we'll say OA and OB is the radius of the circle. Okay, that's why they are congruent. Now we can also take, see, OP and OP. Okay, so OP and OP, they both are what? Common side. So we'll say segment OP is congruent to OP itself, or segment OP. You can write that. Okay, why? Reason for this will be common side. Okay, so this is what we got. Now if you see, this is OA, OB, they both are what? Hypotenuse, and this is one side. So by hypotenuse, see, hypotenuse side test. So we can say, therefore, triangle OPA is congruent to triangle OPB. Okay, why? The reason is hypotenuse side test. Now if you remember hypotenuse side test, it says that if you have two triangles and there is a hypotenuse here, okay, this is the hypotenuse AOB and this is P. So if OA and OB, they both are same, okay, that is hypotenuse is congruent, and OP is congruent to OP itself. So there is one side which is congruent, which is the common side, and by radius of the same circle, the hypotenuse is congruent, OA and OB. Correct? Therefore, we can say that if the hypotenuse and one side is common, by hypotenuse side test, the two triangles are congruent. Okay? So I hope you understood. Now, we have proved that these two triangles are congruent. Therefore, we can say that from this here, AP and BP. So we can say segment AP is congruent to segment BP. The reason for this will be CSCT. corresponding sides of congruent triangles. Okay, so I hope you have understood this. Okay, now the converse of this theorem is over here. Okay, which says that a segment joining. So here, if you, before reading the statement itself, if you try to think of the converse in this, see what does the theorem say in this? If you draw a perpendicular, it bisects the chord, correct? See here in the converse, what will it say? If you draw, okay, sorry, if you if you draw a line from the center, or a segment, if you draw a segment from the center in such a way that it divides the chord, okay, if it divides the chord into equal parts, then this segment is called, it is perpendicular to the chord. That's what the converse say. So if you read this statement now, a segment joining the center of a circle. So what does it say? So I'll make changes in this figure itself. Okay. So here a segment joining the center of a circle. So here a segment joining the center. So this is the center of a circle and midpoint of its chord. So this is the segment which is joining the mid. So this is chord AB. Let's say P is the midpoint of the chord. For this theorem I'm talking about. So P is the midpoint of the chord is perpendicular. So we are saying a segment joining the center of a circle and the midpoint. So chord AB ka midpoint is P. So this segment is dividing A. This segment OP is dividing AB into equal part. So if this is happening, then we have to prove that this chord, this segment is perpendicular to AB. Okay, I hope you have understood the converse, what it says. Okay, now we'll look at the proof for this. Let's see. So we are looking at the proof. Okay, we're looking at the proof of the converse of this theorem. Okay, so here is the figure given. What is given to us is a segment joining the center. So what is the center? Let's say O is the center, as it is. Okay, O is the center of the circle and the midpoint of its chord, and you say that P is the midpoint of AB. Sorry, or you can say midpoint of chord AB. So P is the midpoint of chord AB. That means we can say that AP is congruent to BP. So this and this, they both are congruent. Okay. Now what are we supposed to prove? If that happens, then is perpendicular to the chord. That means OP should be perpendicular to AB. We need to prove. So we are constructing OA and OB, which is the radius. So join the radius OA and OB. Okay. So we are doing that construction here. It's already done. Now let's look at the proof now. Now we need to prove that OP is perpendicular to AB. So how are we going to approach for that? So if this should be perpendicular, which we need to prove. We need to prove that this is 90 or this is 90. OPA and OPB should be 90 degree. Correct? So because we need to prove that it's perpendicular. So to prove that the lines are perpendicular, we need to prove that this angle should be 90. OPA or OPB. Okay. So we need to find that as 90 degrees. So let's find it out. We'll take two triangles here again. Same way, it's the similar way of how we did for this theorem. Same way in the proof it is. So we'll take in triangle OPA and triangle OPB. Okay. we can say that AP is congruent to BP. Why? Because it's given. Yes or no? AP is congruent to BP. It is given to us. Now OP, okay, OP is congruent to OP itself. Why? Because it's common side, correct? Now if you see OA and OB, why are these two congruent? Because it's radius, simple. Because OA and OB, they both are radius, okay? Therefore we'll say OA is congruent to OB. Why? Radius or radii of the same circle, correct? So radii of any circle, it can be any radius, it will always be same of that same particular circle, okay? So now if you see, all three sides of the two triangles are congruent, correct? So we'll say therefore triangle OPA is congruent to triangle OPB, correct? So we have proved that these two triangles are congruent by what test? By S test, side, correct? So you have proved this. Now we can say that OPA and OPB, okay, angle OPA is congruent to angle OPB. Why? CACT, corresponding angles of congruent triangles. Okay, I hope you are understanding this so far. Now if you see, can we say angle OPA plus angle OPB equal to 180 degree? Why is this so? OPA plus OPB is 180. Why am I doing this? Because these two angles OPA and OPB, they are forming a linear pair. So we write the reason: angles in a linear pair. Okay, if you have forgotten what is angles in a linear pair, I would say if there is a straight line, okay, and if you divide the straight line into one or maybe two parts, then the sum of the two angles, which is let's say x and y, okay, so x plus y is 180 degree, okay. Or if you have, let's say 1 2, how many divisions you have? X, y and z. If there are three divisions of one straight line, okay, then you'll get x plus y plus z equal to 180 degree. This is also called angles in a linear pair, okay. There can be any number of angles in a particular straight line, so if that many numbers, the addition will always be 180 degree, okay. So that's what this says. Now if you see, if I replace OPA with OPB in this, what will happen? So I'll say OPA as OPB because it's congruent. So I'll say this as equation 1 equal to 180 degree. Reason for this from equation 1. Now if you see, 2 times angle OPB is equal to 180 degree. Therefore angle OPB is 90. Now OPB is same as OPA, therefore we can say angle OPA is also 90 degree, correct? So we have got the two angles OPA and OPB as 90 90. So if both the angles are 90, then we can say that OP is perpendicular to AB. So OP is perpendicular to AB. Okay, so I hope you have understood this theorem, the proof for it. Okay, now we'll look at some of the examples based on the theorems which we did now, the normal, this one, and the converse of it. Okay, so let us see. So here are some examples which we are taking. Okay, let's see the first example, first question. the first question which says radius is 20 centimeter. So OD, okay, OD is 20. So I'll just write it, OD is 20 centimeter. Then distance of a chord from the center. So this distance of a chord from the center of a circle is 12 centimeter. So distance from the center to the chord is 12. So this is 12 and this is 20. So I'll say OP is 12 centimeter. Now find the length of the chord, meaning we need to find CD. To find length of the chord, that means to find CD. Okay. Now if you remember the theorem which says that if you draw a perpendicular, okay, if there is this chord, there is this line, if it is perpendicular, then it will divide these two into equal parts, correct? So here okay, it's given that it's perpendicular in the question itself. Okay, so now if this is perpendicular, then these two CP and DP, they both are congruent. Okay, now if you see, consider this triangle AOPD. So let's consider in triangle OPD. Okay, in triangle OPD, we can say angle OPD is equal to 90 degree. Angle OPD is 90 degree. Therefore, if one of the angle is 90 degree, we can, that we can apply Pythagoras theorem, correct? Therefore, what does it say? Hypotenuse square, which is OD square, this is square, hypotenuse square is equal to one side square plus other side square. Therefore, it will be OP square plus PD square. Now let's substitute the values now. OD is 20 square equal to OP is 12 square plus PD square. Okay, we need to find PD. Therefore, we'll say PD square is equal to 12 square comes this side. It becomes 20 square minus 12 square. Correct? Now, if you find the square of this, which is 400 minus 412 ka square is 144. Okay. Now subtracting this, you get 256, and therefore when you take square root of both, you get 16, correct? Because square root of 256 is 16. Therefore I got PD as 16. But if you know, what will CD be? CP plus PD. Yes or no? CD, this whole length is CP plus PD. But you know that, where is it? I've written CP is congruent to PD. You know that CP is congruent to PD. Correct? So I can write CD as, so instead of CP, or I write CP as PD. So this will be PD plus PD. Therefore, CD will become PD plus PD, which is 2 times PD, correct? Therefore, PD is 16. So we can say that this is 2 into 16, which is 32 centimeter. So CD means the length of the chord is 32 centimeter. So we'll say, therefore, length of the chord is 16 centimeter. Okay. So what we did here, we found the first part, the half part of the chord, the length of the half part, okay, which is PD as 16, and then we said that CD is CP plus PD. But you know that CP and PD, they both are congruent, so I substituted this CP as PD itself. Okay, so CP is PD plus PD, which is 2 PD, and then PD is 16. Okay, so that's 32. That's your answer for this. Sorry, this is 32. Okay, I hope you have understood this sum. Let's take another question. Okay. Okay, so this is another question which we are taking. So the question says, center of two circle is O. Okay, so here as you can see, these two are concentric circles. Okay, chord AB is bigger circle. So chord AB of bigger circle intersects the smaller circle in P and Q. So this is chord AB, which is the bigger circle का chord that intersects at P and Q of the smaller circle का chord. So PQ, I'll say, I'll write it here. PQ is okay. So we are looking at the proof now. It says that, or if you can see from the diagram itself, PQ is the chord of smaller circle, and AB is the chord of bigger circle. Correct. Now we'll take a central point here. Let's say this point is name it as, let's say, Z. So this point is Z. We'll do a construction here. Okay. Now this construction will not be taken in the picture. Let's consider this Z as the center of chord AB. So what are we taking? Z is the center of chord AB. You can say chord AB or PQ because they both are concentric. So chord AB and PQ. Okay, Z is the center. Now if you see, Z is the center, right? So can we say for a bigger circle, for this bigger circle if I consider, can I say AZ is equal to ZB? Because Z is the center, so chord is divided into equal parts. So if I consider for bigger circle, okay, I hope you are understanding. I'll repeat it once again. Z is the center which we are taking. Okay. Now if you consider the bigger circle, we can say that this center, it divides this the chord of the bigger circle into equal parts. That means AZ is congruent to ZB. Yes or no? Congruent or equal, whatever you call it. So AZ is congruent to ZB. Now if you see, can I write AZ as AP plus PZ? Okay, for the reason for this will be because Z is the, or you can say OZ is the bisector of AB. So OZ is the bisector of AB. Okay, so that's the reason for this, for AZ equal to ZB. Now we can say that AZ is AP plus PZ. Why can I write this? Because APZ, because P is in between A and Z. If you remember the very first chapter, basic concepts in geometry, we did this betweenness. Okay, if this can be written, if P is in between A and Z, then we can write AZ as AP plus PZ. So we are doing that. So AZ is AP plus PZ. Same way, ZB is ZQ plus QB. So we'll say ZQ plus QB. And also for this, we can write, okay, for this we can say ZQB. That means Q is in between Z and B. See? Okay, so this is what the reason for these two to write. Now So here, so we wrote this. Now if you see, Z is the midpoint of PQ also. So we'll say Z is the midpoint of PQ. Therefore, if Z is the midpoint, can we say PZ and ZQ, they both are congruent? PZ is congruent to ZQ or equal to ZQ. Same thing. Okay. Therefore, this is first and this is second. So we can say AP plus PZ from the first, and ZQ can be written as PZ itself. Why? Because they both are congruent, plus QB. Okay, so this is what we get from both 1 and 2. Therefore, PZ goes, you get AP equal to QB. So we got AP equal to QB or BQ. So we'll see one more question here, okay, and we'll end this topic. So it says we have to show that if a diameter of a circle bisects two chords, so the diameter AB bisects two chords, see XY and PQ, it bisects, meaning XY and let's say this is these, or let's name this as G, this as H. So XG and GY, they are congruent, and here also this and this, they both are congruent. Why? PH and HQ, they both are congruent. So if that happens, then those two chords are parallel to each other. So we need to prove that this chord XY and PQ, they both are parallel. That's what we need to prove. Okay. So in order to prove these two XY and PQ to be parallel, what are we supposed to do it first? If I prove this angle, okay, this is the construction which I have taken, X cube, okay. Now if I prove the alternate angles to be congruent, okay, if I prove alternate angles to be congruent, can I say by alternates angle test, I can say that XY is parallel to PQ, correct? So we have to prove that alternate angles are congruent first. In order to prove alternate angles congruent, we need to prove that the two triangles, this and this, will be congruent. Let's see the proof and you'll understand it better. Okay. So here the proof, it says a diameter, so diameter AB is the diameter, okay. XY and PQ are the chords, okay. So that is given, and AB, okay, AB, the diameter, is bisecting both the chords, okay, which is given to us. Therefore we can say XY is, XG is equal to or congruent to GY, and PH is congruent to HQ, correct? Because this, they both are, the diameter is bisecting both of them, okay. So now let's see. Okay, so this is given to us, and what are we supposed to prove? Then those two chords are parallel to each other. So we need to prove XY is parallel to PQ. Okay, so this is what we need to prove. Let's see the proof. Okay, the construction which we are doing, we need to write that also. So we have done the construction as join radii XO and QO. Okay, so this is what the construction we have done. Let's add one more point in the construction. which says we are extending this also. So we are extending what? Join radii XO and QO, and also PO and YO. Okay, so we have joined PO and YO also. Okay, so now let's see the proof. See, I told you this considering this triangle and this triangle, but if we consider XOY and POQ, it will be easier for us. Okay, so let's see the proof. Now we'll consider the triangles in triangle XOY and XOY and triangle POQ. Okay, if we ignore this, ignore GO and HO. Okay, just consider XOY, this triangle, and POQ. Okay, so this is what we are considering. Now we can say that XO, okay, XO is congruent to PO. Why? See, XO is congruent to PO because radius of same circle. Yes or no? Same way, I can say PO is congruent to QO. Sorry, YO is congruent to QO. Same reason. Okay, so I'm not writing that. Now, if you see XOY is congruent to POQ. Why? If you think of the reason, sorry, an angle POQ. Okay, so the reason for this will be vertically opposite angle, because it's forming like this. So this angle and this angle, they both are congruent. So we'll say vertically opposite angle here. Now we have proved that, therefore we'll say triangle XOY is congruent to triangle POQ. The reason for this will be SAS test. So by SAS test. Okay. Now if we see if these two triangles are congruent, can we say angle, this angle, okay, YXO is congruent to this angle, which is PQO. Why? CACP, by corresponding angles of congruent triangles. Therefore, if alternate angles are congruent, we can say that XY is parallel to PQ. Therefore, and with this we can say and XQ is the transversal. Okay, so if this is the transversal, therefore XY is parallel to PQ. Why? Converse of alternate angles theorem. Okay, so I hope you have understood this question. Okay, so this is it from my side for this topic. Okay, there are more questions which I think you will be able to solve. Okay, so we did the theorems, the basic theorems on the chords in this video. In the next video we'll be taking a more further looking at some more theorems and questions based on those theorems. Share it with your friends. Okay, and thank you for watching.